Now, maximum and minimum value function. And we get the maximum and minimum value of the function. We get the stationary point, turning points, and maximum and minimum turning points in the function. That's what I want to look at now. So what I want you to do for me now is just to calm down. Ensure you follow the exposition I'm going to be giving you guys now. Now, basically, what you have to do, you must know how to differentiate. That's the major thing. You must know how to do what? To differentiate. You must know how to differentiate. And again, you must know the meaning of successive differentiation. We have the over ds, the square over ds squared, and the rest. You know what we are talking about. Now, take note of this. If your dy over ds is equal to 0, or at dy over ds is equal to 0, you are going to have what we call a stationary point or turning point. You have a turning point or a stationary point. And to check the maximum or minimum turning points, you are going to differentiate it again. And you are going to have d square y over ds squared. Now, if your d square y over ds squared is positive, you are going to have the minimum turning point. You have the minimum turning points. Then, if your d square y over ds squared is negative, you are going to have the maximum turning point. That's what you are going to have. So, take note of this. If your d square over ds squared is positive, you have minimum turning points. If your d square over ds squared is negative, you have the maximum turning points. Please take note of that. It's very, very, very important. But at your d square over ds squared is equal to 0. That's not equal to 0, you have turning point or stationary point. Then, if your d square y over ds squared is equal to 0, you're going to have what we call point of inflection at d square y over ds squared is equal to 0. Now, in the course of this class, we are not going to be looking at the point of inflection of a particular function, but we're just going to be looking at how to get the maximum and minimum turning points and maximum and minimum values of both x and y that will give us the minimum turning point and the maximum turning point. Now, for example, obtain the stationary points or the turning points and state the maximum and minimum turning points of this function. Y is equals to x cubed over 3 minus x squared over 2 minus 2x plus 5 is the first thing we're going to look at now. We're going to state to check the turning points of this function. We'll check for the maximum and minimum turning point of this same function. So let's go. Now, the first thing, remember, at the square over ds squared is equal to 0, we're going to have our stationary point or our turning point. Don't forget that. So let's differentiate now to get our turning point. Our turning point, we're going to have dy over ds. Differentiate is going to have 10. The denominator doesn't have x. So you forget about the denominator, differentiate only the numerator. We're going to have 3 times x, 3 minus 1, we're going to have 3 x squared over 3, 2x, 2 minus 1 is 1 over 2. Differentiate is going to have minus 2 plus 0. Then, if we equate this derivative, because at dy over ds equal to 0, we're going to have our turning point. So we're going to have something like this. Then we're going to have this, we come to this, we're going to have x squared, this, we come to this, minus x, minus 2. And this one now, these are the over the x. If this is equal to 0, if this x squared minus x, and this is equal to 0, then we have our turning point. So what is the critical value of x at this point now, at this turning point? So let's get turning points at the value of x at this turning point. Now, x squared minus x minus 2 is equal to 0. What is x? Now, this is called a quadratic equation. It's called a quadratic equation because it's a polynomial equation to degree 2. It's a quadratic equation. To solve this one, we're either going to use your complete square method, quadrature method, or the what's it called? The formula method. Or use your calculator to also do it, to also get the answer. But in the course of this class now, I'll be using just the quadrature method. Let's do times, that's 2, that's what's the of this x squared? 1 times minus 2. That is 1. So by using the value of x squared to multiply this minus 2, that is what you do. Then the next thing, you check for two numbers, you multiply, or give you minus 2. Add them to give you the equation of this x, which is minus 1. What are those two numbers? You add them, then we are going to have, let's have something like this. Let's write 2 times minus 1. What is that? Can give us minus 2. 2 minus 1. That's going to give us 1. It's not minus 1. So that is not 1. Let's change sign now. Let's do minus 2 times 1. It's still minus 2. Minus 2 plus 1 and minus 1. This one will work. 1 multiplied gave us minus 2. Then we added it, gave us minus 1. That will work. So I'm going to remove this minus x now. And I'll replace it by minus 2 and plus 1. So I'm going to have like this x squared minus 2x, then and plus 1 x minus 2 is equal to 0. That's what I'm going to have. And this is how to solve quadratic equation using the factorization method. So we do this now, I'm going to factor out x. X is common. Only 1 x will be here. Remove this x, 2 will be there. Then we do this 2, just 1 is common. 1 is common. Just 1 is common to be there. There is nothing actually common. So just 1 is common. Move the 1 out. And it's equal to 0. The next thing, p equal to this bracket. P equal to this bracket. We will have x plus 1. Then equal to 0. Pick any of these two brackets. We have x minus 2. Also equal to 0. So we will have something like this. And lastly, then make s the subject of the formula. Or we will have this. So now you have this. We do use or. So or pick any of the two brackets with the same thing. X minus 2 is equal to 0. Then x here will be equal to minus 1 or x will be equal to 2. These are the critical values of x at turning point. Now, which of these is the maximum turning point? Which of these value of x is the maximum turning point? And which of these value of x is the minimum turning point? Look at this, I'm trying to get here. Look at it. Don't forget our turning point or our first stationary point. The next thing, how do you get that? Equate your d1 by dx to 0 and solve for the values of x. Those are the values of x at your turning point. Now, which value will give us the maximum? Which one will give us the minimum? To check that, you are going to find the second order derivative of this first of the function you differentiated before. So what you do, you go to differentiate it again. Then after that, we find how you put this value and check. If it is either less than 0 or negative, it means you give us the square of the x squared is negative, that will give us the maximum turning point. Then if the square of the x squared is positive, that will give us the minimum turning point. So let's go. So differentiate this again. You get the square y over the x squared will be equal to differentiate again. We have 2x minus 1. Differentiate this, you have 12. Differentiate this, you have minus 1. Differentiate this, you have 0. So at s equal to minus 1, we are going to have 2 times minus 1 minus 1. Now give us what is 2 times minus 1 minus 1. 2 times minus 1 is minus 2. Minus 1 now give us minus 3. That this is negative. So this is going to give us maximum turning point. That's going to give us the maximum turning point. And it's also going to give us the maximum value of y in the function. Then at s equal to let's say 2. At s equal to 2. At s equal to 2, then we're going to have the square y over the x squared to be 2 times 2 minus 1, now give us 3. So 6 minus 3 now, and just 4, let me write that. 2 times 3 is 4, minus 1, now give us 3. So this 3 is positive, it's positive 3. That give us the minimum turning point. That give us the minimum turning point. So this x, at x equal to 2, we have the minimum turning point. That will give us the minimum value of y. Now, how do you get maximum and minimum values now? What you do? Go back to this y, place x equal to minus 1. And then equal to minus 1, you are going to have your maximum value of y. Don't check it, just do it. Maximum value means the highest value for y will come when x is equal to minus 1. Check it. So this give us the maximum, this give us the minimum. And then we'll do 2. So as I go to minus 1, we have the maximum. Then go to 2, we have the minimum. So that is how it is done. So you can go and check the values of y now, the maximum value and the minimum value of this function. So go and check it. Remember I told you that the one that will give you the maximum turning point here will give you the maximum value for y. What will give you the minimum turning point give you the minimum value for y. Now let's check to see what you are actually trying to see. Now, another example. Obtain the maximum and minimum turning points. Obtain the maximum and minimum. I can ask you obtain the minimum only. Maybe I want to ask you a question now. Actually, obtain the minimum turning point of the function y is equals to 10s cubed over 3 minus 20s squared, then plus 30x. You just need to do this. So you give us the what they call the minimum turning point of this. So what you do, first you differentiate. First you differentiate. So 3 times 10, then 3 minus 1 is 2 over 3 cancel this already. Minus this out and is 40. Yes. Plus whatever this other one, you get 30 and you have 30. You need to give us something. You go this one to 0, I don't have turning point. So at 10x squared minus 40x plus 30 is equal to 0. We have our turning point. So if you solve this now, because if you can even divide everything by 10, so it will be x squared minus 4 plus 3 equal to 0. You are going to have. If you want to do this now, you either use your calculator or you use your factorization method or your formula method. It's going to work. You can divide everything 2 by 10. First, division by 10 by 10 by 10. Or 10 can go through everything there. So you start doing it. Well, I'll advise you in a very short exam condition to use your Casio calculator to run it. Use your Casio calculator to run it. So if you do this now, you're going to have x to be equal to either 3 or x to be equal to 1. That's what you're going to have. You try, see if you can do it. Then the next thing we're going to do, these are the 2 critical values of x. The next thing I'm going to do here now is to what? Is to differentiate the case so we know the maximum and the minimum turning points. So differentiate this function again. Let's differentiate this again now. So we are going to have dy square y over the x square now will be. So let's differentiate the function again. So we are going to have 2 times 10. 2 times 10 is going to give us 20x. Then minus 40. Differentiate 10 is 0. So as x equal to 3, I'm going to 3. We're going to have 20 times 3 minus 40. That's going to give us what? 20 times 3 is 60 minus 40. That's plus 20. That will give us 60 minus 40. That will give us plus 20. And when it's positive, minimum turning point. So this is going to give us the minimum turning point. That's going to be the minimum turning point. So at x equal to 1, our d square y, our d square will be 20 times 1 minus 40. That will be 20 minus 40. And then goes minus 20. And if it is negative, we are going to have maximum turning points. So the minimum turning points, the values of x and y are minimum turning point. To get if you do it very well now, what it does is going at x equals to what? 3 will have our minimum turning point. So the minimum turning point occurred at x equal to 3. And what is y at that point? What is just to come to this place, put 3 here. We have 10 times 3 cubed over 3. Then put 3 here, 20 times 3 squared. Then plus 30 times 3. Just do this one. We're going to do this one, we're going to have 0. It will be 0. And y is equal to 0. So this will give us the minimum value of y. That's the minimum value of y. So at this minimum turning point now, our coordinate is x equal to 3 and y is equal to 0. So this will give us the minimum turning point, which is at plus 20. X is equal to 3 and y is equal to 0. So let's look at this question. Let's look at this other question. Obtain the stationary points and all the turning points and state the one that is maximum and the one that is minimum of the function y is equals to 2x cubed minus 5x minus 5x plus plus 5x squared plus 4x plus 2. Look at this. Look at this. So we're going to have first thing you differentiate, you go over the x is equals to 2x. Okay, that's going to give us 3 times 5 is 6 x squared. And that's equal to 10x. Then plus 4. That's equal to 0. So this one is equal to 0. Now what will be the that's equal to 0? What will be the values of x here? 10x plus 4 equal to 0. What are the values of x here? So you do this with your everything 2 by 2. Then you solve it 2. This one now, with the other factorization, first you do this one not set. This one have method to do it. This one have method. This is our A, this is our A here, this is B, this is C. Remember, x equal to minus B plus or minus square root of B squared minus 4AC all over 2A. So use that to run it. Okay, let me just do it to see what I'm going to have. Our B is minus 10. Minus 10 plus or minus square root of minus 10 squared minus 4 times 6 times 4 over 2 times 6. That gives us 10 plus or minus square root of 100 minus 4 times 6. 4 times 6. So let me just say, okay, 4 times 6, that is already 24. Already 24. Then 24 times 4. 24 times 4. 24 times 2, that is 48. That's 48. 48 plus 48, that gives us 96. That's 96. 100 minus 96, that gives us 4. That gives us 4. Then the square root of 4 will give us what? Square root of 4 will give us 2. Over 12. So I'm going to have, and have 10 plus 2 over 12, or 10 minus 2 over 12. So I'm going to have 10 plus 2 over 12. What's 10 plus 2 over 12? That's 12 over 12. Or we have 10 minus 2, that is 8 over 12. That is going to give us 1, or what can go? 4 can go to the 4 here 2, 4 here 3, or 2 over 1, 3. Those are the two values of x. So let's differentiate again to do the maximum and the minimum of these two turning points. So we differentiate the b square y over the x squared is equal to, let's differentiate this again now to see what we have. We have 12x minus 10. That's what we're going to have. This one will give us 20. This one will have 10. The next thing, we're going to put 1. 12, 1 minus 10. That will give us 12 minus 10. 12 times 1 is 12 minus 10. That's plus 2. Minimum. So this is negative. Then let's put 1 and 2 over 3 now. We have 12 times 2 over 3 minus 10. 3 and 1, 3 and 4. 4 times 2, that is 8. We have 8 minus 10 minus 2. We give us the maximum. So we give us maximum turning points. Occur at s equal to 2 over 3. Think of that. The minimum, the maximum is this, because this one gave us a negative value. Or negative, and we tested it. So this is the maximum, and this one is the minimum turning points. So obtain the turning point. Obtain the turning point. Just obtain the turning points. Just check for the value of s at this turning point of the curve. Y is equals to 17 plus 6x plus s squared. So you just obtain the turning point of this curve. Y is equals to 17 plus 6x plus s squared. At turning point, we have the 1 over the x, which is 0 plus 6 plus 2x. So at this is equal to 0 now. Let's go to 0. 6 plus 2x equal to 0. What will be the value of x? We have 2x equals minus 6. We have to by this. You have s to be equal to minus 3. So we have minus s equals minus 3. We are going to have s to be equal to what? Minus what? Minus 3. We're not to look for the maximum or minimum turning points of this. We just have to look for the turning points. Turning points of course are equal to what? Minus 3. That's what we have the turning points. So the next one we're going to look at now is the curvature and radius of curvature of a particular curve. Now let's go. Ensure you practice this. It's very, very, very important. So let's look at the curvature and radius of curvature of a curve. Alright, now let's look at curvature and radius of curvature. Curvature and radius of what? curvature. Now, the curvature of a curve can be obtained by the relation c is equals to d square y over dx squared over 1 plus dy over dx squared, everything is power 3 over 2. This is how we get the curvature of a curve. While the radius of curvature is equal to 1 over curvature, or you can also say 1 plus the y over dx squared, everything is power 3 over 2, then over the square y over dx squared. That is like this, or you just take the inverse of this curvature. The inverse of this is going to give us the radius of the curvature we're actually talking about. The radius of this curvature we're actually talking about. For example, obtain the curvature and the radius of curvature of this curve y is equal to x squared at 1, 1, 1, at 1, 1, y is equal to x squared. What will be the curvature and radius of curvature of that curve? So what you do to look at the meaning of this formula. This means differentiate the function 2 times. That is the meaning of this. This means the over there, this should differentiate this once and square it. That is the meaning. So I don't know differentiate this once and then we'll square. So differentiate it 2 times, put it here, differentiate it from put it here. And that's the end. That's the end. I'm not going to do much more. What you have to do, know the formulas. If you know this one, I don't know primary this again. Just know this, just take inverse of this, that will give us the answer. Okay, look at this. Yeah, we need to differentiate once, differentiate again. So we have the y over dx. The what is over the other, that is 2x. Then 1, 1 means x, y. So it means x is equal to 1, y is equal to 1. That is the meaning. So in this place now there is no y, we only have x. Anywhere you see x, you just put 1. So this is going to have 2. Because 2 times 1 is 2. So I'm going to have. Then the next thing I'm going to do, we'll differentiate again to have the square y over the square. So we're going to have 2 times, we're going to have 2. Differentiate square, so we're going to have 2. Then our x equal to 1. X equal to 1, there will not be a place here to put it, but there's no s here. We all have 2. So the next thing, forget about that, since there's nowhere to put s or y, and leave it like that. The next thing, anywhere see the square over the square, you put 2. Anywhere see the over the s, you put 2, and put is 2, and s equal to 1. So put 2. So we have curvature to be, we have 2 over, we have 1 plus, this one is still 2 square, which is power what? 3 over 2. This one is going to give us 2 over, okay, this 2 square is 4, 4 plus 1. It's not do square before you do that in plus, it's multiplication before addition. So we have 4 plus 1, that is 5, this power 3 over 2. So this will be the curvature. That will be the curvature. Why the result of curvature will be the inverse of this. So let's get the decimal equivalent for this and that of our radius of curvature. We'll do one more question, then we are going to go already. So let's check for the decimal equivalent of this. So we are going to have 0.179 for our curvature. Why the radius of curvature will be 1 over curvature, which is 1 over 0.179. That will give us 5.6 units. So both of them are in units, not square units, because we are looking at just radius and curvature, which is one of length. Then let's look at this other question before we go. Obtain the curvature and radius of curvature of this curve. Y is equals to s squared. Y is equals to s squared. Let's look at another point now. We looked at 1, look at 0, at this point, 0, 0. This one means s is equal to 0, y is equal to 0. At that point, what will be curvature and radius of curvature? So let's do dy over dx will be what? Usually you will have 2x. And when I say put 0 over dx, and 5 goes to 0, we have 0 for the over dx. What about the square y over dx? What I'm going to have? Usually this again, we have 2. That's what I'm going to have. The next thing, next I'm going to go to this formula. The curvature will be the square over dx is 2. Then 1 plus the 1 over dx is 0 squared. This one 3 over 2. Then we must 2 over y square 3 over 2 because 0 square is 0 plus 1 is 1. That's going to give us 2. The curvature is 2. Why the radius of curvature will be equal to that will be equal to 1 over c. 1 over curvature is 1 over 2 half. So the curvature is 2, and the radius of curvature is 1 over 2, which is 0.5. So this is how you calculate the curvature and radius of curvature of a curve. So take note of this. For example, if there is no curve for a straight line, if you have the equation of a straight line, the equation of a straight line we'll be looking at very shortly. Next, maybe another section. In the equation of a straight line, the power of x is always equal to 1. So if you have something like a function like this, let's say y is equals to 2x or x, you see, what is the curvature of this curve? There's no curvature there. There's no curve in that because it's a straight line. That's an equation of a straight line. So since there's no curve there, the relation of curvature will be impossible. Because the square over the x square there will be 0. So it will be impossible to get the radius of curvature because the curvature here is 0. Go and try it. Try this one. Calculate the curvature. The curvature is 0. While the radius of curvature is 1 over 0 or something like a number over 0. And a number over 0 is always the radius of curvature there will be something over 0. If I say if I tell you at let's say at 1,1, you will still give you infinity. Give you something like an infinite answer because there will not be a way to get the radius of curvature for this because there is no curvature. The radius of curvature will be indeterminate. It's indeterminate. Yeah? When number over 0 is always indeterminate. So please, you study what we have done so far. We have done a lot. We use calculus. So look at make sure you practice the methods we are using here. It's just a short way to resolve the calculus problem. Thank you. I'll see you guys in our next class. God bless you. God bless you.